Well, hello, this is Peter with Fiber Design. This is a new laminate program that we just introduced here. This is a laminate analysis program for analyzing composite laminates. The composite laminates are basically FRP laminates, or there's also a common laminate with carbon and also an aramid laminate that's in here. So basically what we do is we allow the user to look at a certain laminate and then pick a thickness, and then you can look at the deflection ratio, and you can look at the maximum pressure on the size of the panel or the laminate panel that you've chosen. And this would be good for engineers, which would be for my clients, and for really manufacturers or anybody really in the business. So it's a free program. So if you'd like to get a copy, just send us a note, either through the video or through our website. We're pretty easy to deal with in that regard. The website is www.fiberdesig.com, fiberdesign.com, without the E. So, looking at the graphic user interface here, on the left is the laminate types and thickness, or it's the laminate here here on the left. So we've chosen two loads to use, 30 PSF and 60 PSF. This, of course, it goes for all three thicknesses of 1/4 inch, 3/8 inch, and 1/2 inch solid laminates. Now, we're not going to do multi-ply laminates like sandwich panels. That is not done in this program. We could do something down the road on that, but there's so many variations on it, on them. There's hundreds of cores available, so maybe if we could get a better idea of what people like to use, then perhaps we might be able to do something with the sandwich panels and give some similar data there. So over here on the left, you can pick the thickness, you can pick the load that you want. The load can be wind load or live load or water loads or whatever it is that you happen to work with. Over here, the next window on the column B is the laminate number, the reinforcements used, the resin used, and the process used to create the laminate. So there are 6 laminates that we've chosen to analyze here that are built into the program here, and it's a drop-down list. So the first one is composed of e-glass. All the glass is e-glass. All of the reinforcements are biaxials. This is just to make it easier, except for number 4. Number 4 is matte only, and this would be something pretty similar to using a chopper gun. So it also happens to be the weakest laminate because there are no structural fabrics in there, just the mats. So the first one is with biaxials, polyester resin, and in a hand layup configuration. Number 2 is very similar to above, except it's infused or in compression mold type of arrangement, type of process. Number 3 uses cross laminates. In other words, it's a mixture of 45 degree and 90 degree laminates, and which makes it a very strong laminate. I just talked about number 4. Number 5 is a hybrid of e-glass and carbon biaxials, built up to the proper thickness. And then number 6 is a mixture of glass biaxials and aramid biaxials, again, and to get the thickness. These last 2 use vinyl ester resins and are infused. So as you pick one, you can see it'll then provide the data across the screen of deflections. For example, we have a 3-foot by 10-foot panel here chosen for the 1/4-inch panel at 30 psf. So the way the laminate works is the span is across the width. The span is across the width, okay, and not the length. We can look at the length, but we didn't do it in this program. So in this case, now you will notice the deflections change as you increase the length, by the way. So we start with 2 by 2. I think on the smaller laminates we go up to I think 4 foot by 10 foot. Then on the larger, thicker laminates, I believe we go up to 8 by 8 is in feet. So you can look here. We've got a 3 by 10 laminate chosen here on line 4. The deflection ratio is 51. And then we also give the maximum pressure and PCI and PSI on that particular panel. And we also give the maximum pressure, and that's ultimate pressure, by the way. And we also give the maximum pressure with a safety factor of 3 in PSF over here in the right column. So that's pretty much what it is, what it's all about. So now we have two sheets here that relate to looking at deflections. This one here, SS means simply supported, and the FF means fully fixed. So they give very different results. So now you may notice here, for example, we've got a 4 by 8 panel here on in the 1/4 inch at 60 psf, and the deflection is almost 4 inches. And look at that. Look at the L over X. Look at the deflection ratio. It's only 12. Well, basically what that means is that it's a warning to the user that you've gone below the safety margin of it's below 1. So you're in a I must say, we won't call it a danger zone, but you certainly want to be aware of that. So. And with, of course, here it means the maximum deflection is just about 77 psf. So there you go. So that's a story on that. You can choose different. For example, if we go up to the carbon one here, it considerably higher. Still a concern. You know, it's still a little below the safety factor of 1. Et cetera, et cetera. So again, that was at 60. If we took the 4 by 8 panel and reduce the load, et cetera, it'll help you. Now the main thing here is we're trying to point out is the key thing that you'll be looking for is the maximum allowable PSF on your panel, and your maximum allowable, and also your deflection ratios. That's really why this program really exists. So there you go. Now there's another sheet that we provide also. This looks at the coupon properties and some of the typical properties of the laminates and the thicknesses. For example, this is number 1. It shows you the weight pounds per square foot, fiber weight, and then much of the usual data: tensile, compression, strengths, modulus, and so forth, so on. And that's all there. So again, you just choose the laminate that you want, and then it'll fill in all the correct data. So that's pretty much it. This is good for engineers. I think it'll help you determine, for example, what your framing should be, what your intervals for your framing should be. Should you set a frame at 4 feet on center, at 3 foot on center, et cetera, et cetera, and when you determine that kind of thing. So it's a program that we think will help, and we hope you like it. So any questions? Ask some questions here on the video. Drop us a note at info@fiberdesign.com, or get on the website. You can get at us that way too. So, or ask questions through the video as mentioned. Okay, very good. Thank you for watching, and we hope you like it.